All right. Okay, so it's recording now. Okay, my name is Sam de Oliveira. I'm a tech here. I have Scott Reinhardt with me. He's going to be helping me demonstrate how to do some soldering. So this is a soldering workshop organized by Dylan from Purple Fire Robotics, and we have a few people attending here in person. So we're just going to cover very basic, the very basics of soldering. Just to familiarize yourself with what you're actually going to be working with if you do this yourself. I have a fume extractor here that's already running, right? Anytime we're doing any soldering, you're going to produce some fumes, and you don't want to be breathing in that stuff. It can be an irritant, it can be a little bit caustic, so it's always good to have that running. Then you have the soldering station itself. It's going to look like this, right? This is actually generating the power which produces heat on your soldering iron. So on your soldering iron itself, there's a rest, and on that rest you may have something like this brass Brillo or a sponge. So before you start soldering, what you're going to do is you would wet that sponge, and it's a good material for you to clean the tip of the soldering iron on. The Brillo is also very useful for that, and the nice thing about the Brillo is it doesn't cool the soldering at all, the soldering iron, so the temperature doesn't change and it doesn't degrade the tip as quickly as if you use the sponge regularly. So one of the things with the soldering iron is the tip will oxidize over time. As you use it, it'll create pitting on the tip. One of the things you want to do before you start any soldering job is you actually want to apply a little bit of the solder to it. Before we go into that, let me just explain a few of the other things that we have on the workstation here. I have my actual solder here. So solder is a term that is used to refer both to the act of soldering the metals together and to the material itself, the filler material that does the soldering. In this case, it's a metal alloy that has a very low melting temperature, and it's much lower than the components that you're joining together. And the good thing about it is that it liquefies very quickly, and then it becomes runny and easy to work with. So it's a special alloy. It's usually composed of tin and lead, and that is actually what you're using to join the PCB and the cable or components together. The other things we have here on the workstation is this helping hands, and this is just a very easy, nice little tool that you can use to manipulate objects and put them close to each other so your hands are free. You can pull the solder with one hand and then have the iron in the other hand, joining the components together. The other thing we have here is just a simple tabletop vise. It uses a little suction cup, and as we turn this little handle, it clamps onto the table. We can turn this in any direction that we want. This can be manipulated in any direction. We lock it again, we open up the vise, we close the vise. This is very nice if we're working with something like a perf board. So this is a perf board, and it's basically a PCB that's unfinished. So if you're working with a more durable prototype, if you're going beyond the point of a breadboard, you may want to put something onto a perf board. And in this case, it has a bunch of, it's a series of holes. It's a good system, and there's a PCB material. And there's the PCB, the actual metallic contacts on one side and a blank side on the other. This is where you would put your components through, and then on this side, you're actually going to do the soldering. So I'll kind of show to the camera here. And now I'm referring my comments to people that are here in person and whoever might be watching. So the perf board's a very nice thing to do prototyping on. Some of the other things that we have here, what should we cover? Okay, covered the soldering iron. This is a solder sucker, and when you have a very large, if you've made a mistake, you've been soldering and you have a large amount of solder on a board that you need to remove, this is a very good way to get it removed. All you would do is you would And actually, I can demonstrate here. This is a perf board that has some random stuff on it, and so if I'm trying to remove some amount of solder at some point in this board, what I can do, I'm going to use my vise here. What I can do is I can heat up that contact on the board, and then with a solder sucker, as that liquefies, this is going to liquefy. Takes a little bit to heat up. As that liquefies, I remove the iron, and then just hit the button, and it pulls in the solder. So it's removed that contact on my board, right? Now, you always want to try to avoid making any mistakes like that, because cleaning up solder is a lot more difficult than it seems. Even using a solder sucker or something like the solder wick, right? The solder wick is a little bit differently, and this looks like a copper braid, right? If I'm trying to remove material from the board, or maybe from a header that I incorrectly placed, what I'm really doing in this case is I'm putting a portion of the wick against my joint, and then I press with the iron. I press the wick into that joint, and I pull it along. Now this is a little tricky because you have to make sure you're applying good pressure, and then you're kind of pulling the wick along, and then you're pulling the solder into the wick. Again, it is tricky. It's a little bit of an art to it, and you want to avoid doing any mistakes like that as much as possible. But it is possible to clean up a bad solder. So let me return this to you here, Scott. The other things to note, the types of wire you might be using in the lab. You might be using stranded core or solid core. So an example of solid core wire is right here. Let me clip off a piece here. I'm using a set of diagonal cutters, and I clip off this piece of solid core wire. I also have a set of wire strippers here in the lab. By the way, Dylan, let me know if this is all off camera and I can just kind of... You're good. Okay. So I have a set of wire strippers here, and the wire stripper it can cut on the very bottom, and then it has a different size gauges all along the tool. And what I want to do is I want to look on my wire, and it'll tell me the gauge of the wire. This is a 22 gauge wire, and I have a 22 gauge measurement here on my tool. So I line up my wire, maybe a ½ inch or however much contact space you need. I line it up, I press, and I pull. And it removes that section of the casing on the wire, of the sheath. So this is a solid core wire, and generally it's going to be it's going to be more conductive, but it's not quite as pliable. So in certain applications where you have to have mechanical considerations in effect, where this wire might be getting regularly bent, maybe you want to go with a stranded wire instead. And ultimately, an electrical connection is an electrical connection. But besides just the electrical contact that you're making on your application, you should think, is there going to be some mechanical effects that I should take into account? And in those cases, you may want to use a stranded wire that's even of a lighter gauge. But again, it may not conduct, it may heat up more. So there are other considerations in effect as well. So there, Scott has some stranded wire, and actually, you know, if he's joining those together, he's showing how you might join the wires together. He is just braiding them together, and we're going to do that as a demonstration. We're all going to go through that, and then he can apply some of the solder to that end and make a nice mechanically firm and electrically conductive connection. So before we start with the actual soldering, the one thing to be aware of is that it's a little bit of an art, right? So it's not entirely that you have to follow a system. You'll get better as you work on soldering. But one of the things you want to be aware of is that speed is critical with this, especially if you're working with a heat-sensitive piece of equipment. You may burn out integrated circuits if you leave your iron on too long on the PCB. So you do want to move quickly. And the really important part of soldering is that you don't just heat up one of the components or only the solder. You want to heat up the surface, the component, and the solder all together. And you want to try to create a nice clean contact. And in this case, more is not better. You want to just have the right amount of solder. It should look like a very nice clean connection. We're going to do a very basic one here. So we're going to start with just putting on headers onto a board. And actually Scott can do the same, and we'll see just which one comes out a little bit better. So here I have some headers. This is a very common type of soldering job that you might do, is simply putting on headers onto a perf board, for example. So I can take my diagonal cutters and cut a strip of these headers away. So I'm going to cut 4 headers out of this. And I'm just using this as an example, but these headers could be soldered onto anything. It could be a motor control board. Here, let me give you a strip of these. It could be, there's lots of things that use headers where you would put it back into a breadboard. And so this is something that you will commonly find you have to do as far as soldering. So again, one side of this perf board has the actual metallic contacts, and the other side is where I put my components into. So the side that I'm soldering onto, right, this is where I would actually put the smaller side of the headers through, right? So the other part of it is you want to keep your components nice and even. So I'm going to place these headers through the board. And actually, I can use the breadboard as a support. So I place the headers onto the breadboard, and I'll place my perf board over that. Now you'll notice that this is a little uneven here, and it's fairly simple fix. I just have to put some headers on the other side. You'll have to work with whatever components you have. Sometimes they'll be tethered onto something. Just find a way to make sure that your headers go on nice and even. So I remove that off the breadboard. I put this on the other side of the breadboard, and I can just lay that over.
Your work surface isn't on.
Okay, let me show here. Okay, so again, I took the perf board. I placed 2 sets of headers just to keep the perf board nice and even for when I actually do the soldering onto. And this is just an example, so it doesn't really matter where the contacts go. So this looks nice and even. Now, before I start soldering, I want to apply a little bit of the solder to the tip. The reason I do this is there's a material called flux within this type of alloy. Not all of the solders have it. Some do not have it, and you would have to apply the flux onto the surface that you're soldering beforehand. The reason you do that is to prevent oxidation. As you heat up a metal, it will naturally want to oxidize. The rosin flux, which is this liquid right here, you can apply it with a small brush. So there's a brush here, and there's the rosin flux. If you're working with a solder that doesn't have flux, it's not a flux core solder, you want to apply a little bit of this as you're working along. It makes it more difficult and more tedious, but for certain applications, you would be using this regularly. For very simple circuits, you can get away with just using the rosin core solder, and you'll be fine. But we apply a little bit of that just to get that rosin onto the tip and prevent that oxidation. It helps preserve the tip of the soldering iron. And I use that Brillo brush, that little brass brush, and just clean the surface a little bit. So I removed most of the material, but it's ready now to actually be used on the components. So again, as I'm soldering, what I'm doing is I'm heating the metallic contact on the board and the header at the same time, and then I'm kind of running my solder into it. And I want to try to do it relatively quickly. Once you're spending more than 4 or 5 seconds on a contact, it's probably too long. You could potentially start burning components. The other thing to note is that you do not want to use too much solder, as this will run over onto the other contacts. So that's just, you want a nice conical shape on the header or on your contact, and then that's about it. So Scott's doing his own over there. It takes surprisingly very little to make a nice mechanically secure connection. So it cools fairly quickly, and now the solder is on there fairly solid. I mean, you really could place it into any breadboard, any component, and it's going to stay on there pretty good. Again, if you mess up, you have the solder sucker and the solder wick that will help you take that off. So how did yours go, Scott?
You put it on and took it off.
Oh, okay. These are throwaway, so we can use these, and we'll actually do our example on these. Am I forgetting anything, Scott? Is there anything I should add? Okay. So the other thing is, that's just one example that we're going to work with. So that's a very simple putting headers onto a board. The other thing we want to do is maybe join 2 wires together. In this case, we'll use the stranded core. And this is stranded core wire. I'm just going to cut off a piece and join it to itself. Scott already did that actually, but he may have a little bit of a different thought on the best way to do it.
You need to take and twist it, which is probably the most common. But also, it's not a smooth one. I'll show you 2 different ways. Because the biggest thing to not forget is if you're joining wires that are going to be within something, you're going to use the heat shrink that goes on it. I would say the most common thing I mess up on
is forgetting to put the heat shrink.
Before I solder it together. Or leaving the heat shrink too close to where you're soldering. Have you ever seen this stuff?
Yeah.
Okay. So you know how it like shrink, and if the wire heats up, guess what? The heat shrinks, so you don't want a piece that's too tight, which is good.
That's a good point. So what he's talking about is, if you're using a heat shrink tube, you're going to cover that connection after you make it. You want to make sure you slip that on before you start the job, because if you have 2 components that are in place and you forget to do so, you're not going to be able to place this tube over it afterwards. The heat shrink tube is just something that you do to protect the contact that you make.
It's a lot cleaner looking than using electrical tape. And tape eventually falls out. If you guys are building something you want to be sturdy, you're probably going to end up double heat shrinking. One on and then go up a size.
The other thing is, so this is stranded wire here, and what I'm doing here is I'm just kind of braiding it together, and I'm actually going to tin this a little bit with some solder before I join them together. So what I can do is I can put these in my helping hand here. Let me lower this and bring my helping hand into it. And I'm going to put a very small amount of solder onto that wire. So I just bring it along here. It doesn't need to be very much. It's just preparing that surface to join together to the other side of the wire. And you put the other side of the wire here.
These are going to need to have one because of.
It only takes very little, right? But now these are prepared to go together. Now, normally you're joining 2 different wires together. I'm just using 1 strand of wire so that it makes it a little simpler. Before you start the soldering, you're going to slip that heat shrink tube over it, right? And then these, the way I like to do it, I've seen people do this, place them together end to end. That won't be as mechanically secure.
Don't touch the solder to the solder.
What we can do here is braid these together.
You'll see it'll just get separated.
So we braid those wires together. We're going to solder them and then lay them flat. All right.
So let the material generate the heat for the solder to melt onto it.
You gotta use the soldering iron if you want to get joined. It's gotta heat up the two materials equally, then you apply the solder.
Okay.
It cools very quickly. We can lay that flat.
Now, if I were to just take the raw darts.
So now I have my heat shrink tube that sits over the wire, the connection that I made. It's a very strong connection. I can actually pull this pretty hard and it will not come apart. This is nice, mechanically secure. And then I would take my heat gun and, here, let me bring it up to the camera. And as I place the heat gun over this heat shrink, it'll all come together and make a very nice, secure connection.
Realistically, that's no thicker than. So when you heat shrink it, and part of what you do,
Let me bring it in. Let me bring you, Scott, into this. You have some good thoughts here. So.
Well, I just showed him a second ago, but when I used a Western Union splice, which the splice itself is really no thicker than the diameter of the total wire with the insulation. And I yanked on it and I actually broke the wire before I broke the soldering joint. Soldering joint, when it's done, should be nice and shiny and smooth. If it's dull or rough looking, it means that's called a cold solder joint. It means you didn't heat up the material before you hit the solder.
One or the other is not, yeah, they're not joining together. You wet part of it, of the solder onto one part of the material, but not the other. So that's why it's so critical to be heating both components together as you apply the solder to it.
Is it possible to burn those solders?
Oh yeah, and if these are kind of, my guess is one size, one heat range. You got to kind of also match up your soldering iron to what you're trying to solder. Maybe you saw like old movies where it looks like a space gun. You know what I mean? And like with this big metal, that's like for doing like house welding. You know, most of what you guys are probably using is going to be the little ones. I'll do one and then I'll have you guys do this.
Yeah, actually, I was going to say they can work through examples if you just supervise them, Scott.
Yeah,
and I'll keep narrating here.
Now, I'm not too worried about where it's going to be.
So if I'm working on a perf board, I'm actually trying to complete a little bit of a circuit. We're going to make a very simple circuit here that just includes an LED and a resistor. So I'm using my little vise
You're using the wire
grip again.
the solder, not just the
Let me
solder.
loosen
Using
this
the
up.
soldering iron underneath the wire. The wire will heat up. Then the wire that's heated up, I touch the opposite side of the soldering iron. If you ever get to, like if you're doing
So
copper pipe or something, it's all the same steps.
here I have an LED and a resistor. Let me bring it up to the camera. And these long legs allow me to go through the perf board and actually bend them so that they'll stay in place. So I have the negative side of my LED here and then the positive side. And I'm just going to place them through my perf board.
Is not a prep, you know what I mean? Look how much thicker that is. See what I'm saying?
And then I can bend them into place here.
Yeah, and no matter how, okay, yeah, you can bend this over, you know, and then wrap it, yeah, but it's just, this was a really cleaner.
There's a few different ways to do this. You could actually use the solder itself as a wire, so you can route it along the circuit, and it's totally fine. For certain prototyping applications, it's a lot easier. In this case, what I'm going to do is I'm going to instead use the legs to make my connection.
And unsoldered.
So I push
You
this
know,
through the
so if
board.
you screw up, you can always change it.
Is there a point of no return, like if you spend too much time on it?
Oh,
So
remember, these are kind of like glued on. So, you know, the amount of time that you're going to spend actually with the solder.
so let me bring this. I'll actually make the joint first and then show you what I have here.
Seconds.
You're closer, so I'll let you take care of it.
Okay. Remember, take a look at your tip, see how it's dirty. You can see how it's discolored. And that doesn't take long.
Now, in this case here, I made a very simple connection between a resistor
I'm gonna tin
and an
it.
LED, right, on the top side of my perf board. Just by using the legs, extending the legs out, and then making two contacts here on the perf board. So this runs from the negative side of my LED. It runs along either of the legs. They're actually running contiguous to each other. And then I made a new contact here. Then on the top side of my perf board, I can run that LED anywhere along the board, push it through one of the holes, and then do another soldering job here, right? So the idea here is you can build a more durable circuit using a perf board and very simple soldering techniques, something beyond just the breadboard. And actually, Dylan, has the audio been hard? Okay.
Okay.
I think for the rest of the time, we'll go to demonstrations and just how people work.
Okay.
Yeah, is that all right?
Yeah.
Okay, so that about concludes it. We'll do this on a regular basis, and we can always update information. Thank you for watching, and be safe. Thank you.
Just gonna-
Should I just